Alrighty, let's take a look at this question. So, a person measuring 1.5 meters in height is walking towards the wall of a building at a speed of 2 meters per second. There's a spotlight on the ground behind them, located 50 meters from the wall. So, you want to draw the wall, the ground, the spotlight, like I did. That 50 meters from the wall won't change because the spotlight is not moving. So, we can put that on there. And the man's or person's height is 1.5 meters, so that also will not change. So we can write that on there. Now, what does change is the person walking towards the wall, and they're walking at a speed of 2 meters per second. Since we can measure that from the spotlight, because they're walking away from the spotlight, that would mean this distance here from the person to the spotlight is going to change at 2 meters per second. So we're going to write that as an x because that distance is changing. All right, and we'll name that with the derivative in a minute. Okay, now we're projecting a shadow on the building wall as they walk towards the wall. So we have a shadow showing up, which would, if the light is kind of like there, the shadow would be this part here on the wall. And that will also change in length because as the person gets closer, the shadow should decrease. So we're going to call that, I don't know, let's call it y, I guess. All right, so I think we've got everything on the picture. If it changes, you label it as a variable. If it stays the same, label it as a constant. Now we're going to name those derivatives. So we look in the question anything that was something per second or per unit of time. So it said the man or the person is walking towards the wall at a speed of 2 meters per second. So that's that distance of x changing. So change in x over change in time. So dx over dt is 2 meters per second. It'd be positive because that x would be increasing. So positive derivative. All right, and then if we keep reading, it says determine the rate of change of the length of their shadow. So that was the y, so dy over dt is what we're looking for. And that little line is so that we can write the snapshot in time. What moment in time are we analyzing this? So it said when they're 20 meters from the wall. So since we called x the distance from the spotlight, when they're 20 meters from the wall and the spotlight's 50 meters from the wall, then they'd be 30 meters from the spotlight. So x would equal 30 meters if we're 20 meters from the wall. Okay, now we just need an equation that relates x and y to each other. We're going to set up similar triangles. So we have like a big triangle where this is y and this is 50. And then we have the littler triangle where this is the person's height, 1.5, and the distance x. Since we're looking for rate of change of the shadow, we could start with that on top. So y is to 50, let's say, as, or you could do to 1.5 as well, however you set this up. And then 1.5 is to x. And then we want to maybe clean this up a little bit. If we multiplied both sides by 50, we would get 75. And then I'm going to bring the x to the top so that we can take the derivative. So x to the negative 1. All right, now we do the derivative with respect to t. So dy over dt. Derivative of the right-hand side would be negative 75. Decrease your exponent to negative 2. And then the derivative of x with respect to t. So dx dt. All right, there we go. And now we would just sub in. I'm probably going to move that x squared to the bottom, so negative 75 over x squared, and x is 30. So I'll put that in, and dx dt is 2. And if you put that in your calculator, you will get negative 1 over 6. For the units, look back at the derivative. So we have y on top, change in y, and y is a unit of length, so meters in this question, over dt, so change in time, and time was given in seconds. So there we go. I probably wouldn't leave my answer like that. I'd write a little sentence saying shadow is decreasing, shadow decreasing. And then if you use the word decreasing, we don't have to use the negative. So at 1 over 6 meters per second. And there we go. Hope that helped.